Lesson 1.1.1, Defining, Rewriting, and Evaluating Rational Exponents. We're going to jump straight to example 1, straight into our notes. Okay, so now example 1. How can the expression 3 to the 6/5 power be rewritten using roots and powers? So first thing we got to do is we got to label our roots and powers. So we're given 3 to the 6/5 power, and now we got to find its root and powers. So the 6 here on top is going to represent our powers, and the 5 here on bottom, just like a tree has roots on the bottom, the 5 here is the root. Now when we go to rewrite this, we're going to use the format. So whatever the root is times the base raised to the power. That should say power. Okay, now filling this in, our base here is 3. We know that's going to be under a square root. Our root is 5. So we got a little 5 out there. And our power is 6. So that 6 is going to be outside. Now just another side note, we can go ahead and rewrite this 2 different ways. And it could be like that. So it could be 5 radical 3 to the 6th power. So both of those are the same thing, both acceptable answers. It helps to know that you can write it both ways because you can start manipulating different problems and be able to solve them a lot easier. So either of those, acceptable answers. Example 2. How can the expression the 8th root of a to the c power be written using a rational exponent? So I'm going to go ahead and rewrite this here on the side and a little bigger. Okay, so remember labeling this stuff. The 8 here is going to be our root. The c here is going to be our power. Right? And remember, just like the last problem, we have our base raised to power divided by root. And when we go to fill this in, our base is a, our power is c, and our root is 8. That's your answer there. C to the 8. So a raised to the c to the 8th power. Example 3. Evaluate the exponential expression without a calculator. So here's where the manipulation comes in. So without a calculator, so we're doing this all by hand. So first one, 8 to the 2/3 power. I'm going to go ahead and write that here. 8 to the 2/3 power. So we know that when we rewrite this, we know that's our power. We know the 3 is our root. So now rewriting this, our root is going to be 3, our base is 8, and our power is 2. I'm going to leave that 2 out there on the outside. And keep in mind that there are 2 ways that you can look at this. First way we can look at this is to restrict it there. So we would find the cube root of 8. So a number times the number times the number equals 8, which would be 2 times 2 times 2 equals 8, right? And it has to be the same number over and over again. Or you can look at it the other way, where you do 8 squared is 64 times, and then you have the cube root on the outside. So a number times the number times the number is 64, and that would be 4 times 4 times 4 is 64, which means anytime you have a set of 3, we have a set of 3 or 4s, that's going to be your answer. 4. So either way you look at it, you'd end up with the same answer. You You just have to choose which one you're going to do first. Are you going to do the root first? Would it be easier to do the root first, or would it be easier to do the power first? So that would equal 4. Okay, and example 3, part 2. We have the 4th root of 81. So the 4th root of 81. And we don't have any powers here, so 81 is not raised to any power. So we're looking for, so since that's a 4 on the outside, we're looking for a number times itself 4 times is equal to 81. And you might have to play around and you might have to guess a bit to find the answer. But it looks like it's going to be, let's try 3. So 3 times 3 times 3 times 3. So if we're looking at this, 3 times 3 is 9. 9 times 3 is, or if you bring that one down, 27. And now 27 times 3 is 81. So our answer would be, since we have 4 sets, four threes in there, just one comes out. Our answer is 3. Right, because 3 times 3 times 3 times 3 is 81. Let's go to example. Oops. Okay, so example 4. Evaluate the expressions square root of negative 25 and square root of 25. So based on the definition of a root, why are the answers so different? So if we go ahead and we solve this, let's say we use our calculators and we put this in our calculators. Square root of negative 25, if we put that in our calculator, that's going to give us a error message. And then when we put square root of 25 in there, it'll give us 5, right? Because 5 times 5 is 25. A little side note, anytime you don't see a number here where the root is supposed to be, we assume automatically that it is a 2. Right, so we're looking for a number times itself. Right, so x times x. 5 times 5 is 25, square root of 25 is 5. And now if we're looking at negative 25, we're looking at a number multiplied by itself to equal negative 25. Right, so if we looked at square root of 25, that was 5 times 5. Right, which means square root of 25 is 5. Now if we're looking at the square root of negative 25, let's say we were to multiply negative 5 times negative 5. Right, because remember we have to multiply the same number to itself. Right, a negative times a negative. That still gives us a positive. So anytime that we're taking the square root of something, it's not possible to have a negative number under the radical, at least not yet. Okay, example 5. When to use a calculator and when to evaluate by hand. So I'm just going to start writing these out. Let's look at the first one here. We have 125 raised to the 2/3 power. So if we're going to rewrite this, remember we have our power and we have our root. Our root is 3 times the square root of, cube root of 125 raised to the 2nd power. So since we're taking the cube root of 125, remember that we need to find a number times a number times a number to equal 125. Just play around with it, and it's going to be 5 times 5 times 5. Right, 5 times 5 is 25, 25 times 5 is 125. So the cube root here, simplifying that gives us 5. And we still have that square up here on top, 5 squared, and our final answer here is 25. So that one, easily do by hand. Let's look at the second one. We have 100 to the 2/3 power. 100 to the 2/3 power. Right, we have our powers and we have our root. So we have 3 times square root, or sorry, cube root of 100 raised to the second power. So if we're looking at this initially, is there a number times a number times a number that equals 100? If you do 10 times 10 times 10, that's way over 100, right? That's going to be 1,000. It's 100, 100 times 10, it's already over. So we don't have any numbers that can multiply there. So let's see if we can do 100 squared. See, 100 times 100 is 10,000. So let's see if we can get right. So I went ahead and I just squared it so far, and that's a 3 there. So now let's try to figure out, is there a number times a number times a number? Right? Is there a number times a number times a number that equals 10,000? And the only knowledgeable answer we can use would be 10 times 10 times 10. We could try that out again, but that's 100. 100 times 10 is going to be 1,000. It's not possible to make it. So when we do 100 to the 2/3 power, that's going to be a decimal number, and you're going to need a calculator. Okay, now looking at the 5th root of 32. So the 5th root of 32. So this one is asking us a number times itself 5 times is 32. If we're playing around with it, let's try 2's. Let's say we have 2 times 2 times 2 times 2 times 2. Let's see if that equals to 32. Let's see, 2 times 2 is 4. 4 times 2 is 8. Times 2 is 16. Times 2 is 32. There's our answer. So 5th root of 32 is 2. So don't need a calculator for that one. Simple math. And looking at the last one here. The 3rd root of 16. And we kind of, if you just look at the previous problem, you can kind of get the answer already. Right, number times itself equals 16. Let's see, that's 2 times 2 times 2. Does that equal 16? 2 times 2 is 4, times 2 is 8. Nope. So that doesn't work. It's not 2. We can try 3, but 3 won't work. So for this one, we're also going to need a calculator, right? Because let's see, cube root of 16 ends up being 2.51984, and so on. It's a rational number. So, calculator for cube root of 16. Let's see, is there any other problems? Okay, so if you guys need further help, tutoring, or visit Plots Math,